Hello, this is Scholar Strive doing some math today. In geometry, we are working with reflections, geometric reflections. So a reflection is a transformation in which every point from the pre-image maps to its point in the mirror image on the other side of the line of reflection. Each point on the pre-image will be the same perpendicular distance from the line of reflection as its image. So let's look at the line. Let's do an example here. So I have a triangle, and we want to reflect it over this line of reflection. And if that was a straight line, that would be better. But here's the line of reflection. And it would look something like that. So here's the pre-image. Here's the image. And the transformation was reflecting over that line. Okay. Now, if we're using coordinates, these are really useful. So, and we're going to use some examples. So, draw the reflection of each over the y-axis, and then over the x-axis. So remember, the y-axis is the one that goes up and down. So here is my line of reflection. So just imagine flipping the triangle over to the other side like a pancake. Flipping the pancake over. And this is how it works. So if they only gave us coordinates, so I want to go down a little bit. And I'll answer these questions later, but let's say, so A is 2, 2. B is 4, 2. And C is 4, 4. So that's where our triangle is. And they wanted to do the y-axis, so I'm going to be using the second one here. So I'm going to take that 2, 2, and what it says is, you take 2, 2, and then do the opposite of 2, so that's negative 2, comma, be the same 2. So if I go to negative 2 over 2, that's right here, and that's A prime. So notice that the distance from A prime to the line of reflection and the A to the line of reflection is the same, 2, 2. Distance from A to the line of reflection is 2. Distance from A prime to the line of reflection is 2. They're the same. So B, I have 4, 2. That becomes negative 4, 2. And then C, 4, 4, becomes negative 4, 4. So what I did off the side, you can do it algebraically, like that. Or you can understand that they're the same distance and you're just flipping it over like a pancake or a triangular pancake. So x-axis, so part B, x-axis. So the x-axis is the horizontal line. If I measure the distance from A to the line of reflection, that's 2. So if I go 2 here, I must go 2 here. Same thing with B. So here's A prime, B prime, and then C prime. And I would be using this one, number 1, for this one, if I wanted to work it out that way. Okay, let's move on to the back page. So reflect over the line, y equals -1. Let me explain. So remember, the line equals y equals x. So y equals x, remember that's just the diagonal. That's y equals x. And then negative x is the negative slope line. Just making sure you guys remember that. Alright, here we go. Reflect over the line y equals -1. So we go to y equals -1, draw our line. So remember, y equals -1 is a horizontal line at -1. Okay. So we're going to measure our distance here. 1, 2, 3. 1, 2, 3. And here's A prime. B prime. And then C prime. Not so bad. Reflect over x equals 3. So x equals 3. 1, 2, 3. We go to the x-axis, count to 3, and then we're going to make a vertical line. Okay, this is where it gets tricky. So A is 1 distance away, so A prime is actually over here. B is 2 distance away, so B prime is actually there. And C is 2 distance away, so it would be here. So we got these overlapping triangles here. So when you're creating your reflections, make sure they're the same distance. Your image point is the same distance from the reflection as your pre-image point. So as you're working on your homework, if you can visualize it, do it this way. Otherwise, use these transformations here: x-axis, y-axis, y equals x, y equals negative x. All right. I believe that is all for now. I'm going to check the next page really quick, see if there's anything. Blank page. All right. Have a good day.